Okay, so today we are going to be doing speed, time, and distance. And the formula is that distance is speed times time. So for this problem, Joe needs to get to work 40 miles away if he drives at 60 miles per hour. We're asked to find how many minutes it will take for him to get to work. So the trick here is that we just plug it into the formula. We have that 40 is equal to 60, the speed, times the time. And then from here, we divide by 60 to both sides. We get that 40 over 60 is the time, or this equal to 2/3, right? We just simplify our fraction. So is 2/3 our answer? Is it our answer or no? It's not our answer, exactly. The reason is that we have miles, and then we have miles per hour, but we're asked to find how many minutes, not hours. So 2/3 is the number of hours, since we're dealing with hours and miles. So we actually have to multiply by 60. We have to get 40. We have to it's actually going to be 40 minutes because we're asked to find in minutes. So make sure to be very careful about these units things. So in general, make sure to remember that miles, an hour are the typical things we use. But then make sure to check for what the problem is asking, what units is asking for, and what units is it giving to you in the problem. So make sure to check for those things. Any questions? Let's move on. Now we're going to cover a formula that helps us find the average speed. The average speed is the total distance divided by the total time. This is something that's actually quite important. So let me explain with this example. Joe drives at a speed of 30 miles per hour for 60 miles. He also drives for 45 miles per hour for 15 miles. Find the average speed. And the classic thing that most people do, they're like, okay, average speed, let's just average the speeds. So they would just do 30 plus 45 divided by 2. And they would get 37.5. This is actually incorrect. Here's the correct way to do this. We use the formula, total distance by total time. So what is the total distance? Well, he goes 60 miles in the first he drives for 60 miles. Then he drives for 15 more miles. Okay, now what is the total time? Okay, so how much time does it take to go this first portion? Does anybody know how much time it takes to cover this first portion, 30 miles per hour for 60 miles? How much time will this take? Yes, Justin said that it's going to be 2 hours. That's correct because we just do distance is speed times time. And then the distance is 30. The speed is 60. And the time has to be 1/2 or 30 minutes. So yeah, it should be 2 hours, sorry. There's 30 miles per hour times 2 hours is going to be the 60 miles. So 2 hours. So 2 hours is the first section. For the second section, it's going to be just 15 distance. Another thing that you should also remember, I just try to use this formula here, but an easier thing sometimes is that speed is distance divided by time, or that time is distance divided by speed. So make sure you remember these as well, because they can be much easier to apply. Now we have to find the time from distance and speed. So we just apply the second formula, this one. The time is just the distance, which is 15, divided by the speed in the second half, which is 45, which is 1/3. So just do 2 plus 1/3, which is just 75 by 7/3, which is 225 over 7. Any questions? And this may seem unclear, like why is it going to be this instead of just this? And that I'm going to explain that in an intuitive manner. And the reason for this is, if you go for, let's say, 100 miles per hour for, let's say, 1 hour, and then you just go for 10 miles per hour for just like 10 minutes. Is the average just going to be 100 plus 10 divided by 2? No, because you're going for 100 way longer. And then in addition, another trap that people fall into is if you go for the same amount of time. Sorry, if you go the same distance. So if you go 30 miles at 15 miles per hour, But then you go 30 miles at 10 miles per hour. People just think, oh, you anyways go the same number of miles, so we just do average them. But again, this is wrong. The reason for this is that even though you're going for the same distance, you're spending different amount of time doing those distances. So make sure to always remember, find the total distance, then find the total time. Always, for every single average speed problem. And we're going to be seeing many more of these types of problems. Any questions? Okay, let's try some more MOEMS problems now. Cindy drove to Mount Rushmore, 1,200 miles away, in her new VW. Because it was a new car, she drove slowly and took 12 hours for the first half of the trip, but then she sped up and only took 2/3 that time for the second half. What was her speed for the second half? And what was her average speed for the whole trip? Okay, so let's just say that Cindy's here, and she's driving for 1,200 miles. And she's driving to Mount Rushmore. She's a new car, so took 12 hours for the first half, and then 2/3 for the second half. So let's say half is here, halfway. So this is going to be 600 miles. This will also be 600 miles. And the total is 1,200. Okay, so it says that she took 12 hours for the first half of the trip, and then she took only 2/3 for the second half. So she took 2/3 times 12, which is 8 hours for the second half of the trip. Okay, so 8 hours for the second half of the trip. What was her speed? Well, again, speed is distance divided by time. And the distance, well, just half of it, so 600. The time, we just found it's 8 hours. So this is just going to be equal to 75. Yeah, so the second half of the trip is going to be 75 miles per hour. So that's our first answer. But now here's the more tricky part of the problem. Find the average speed. And if you remember from earlier, that's just total distance divided by total time. Okay, so total distance divided by total time. Now this is not going to be that hard to do. What is the total distance that she travels across the whole Mount Rushmore? So what is the total distance amongst the whole journey from where she is right now to the Mount Rushmore? Yes, it's just going to be 1,200, because that's just 1,200. That's the total distance that you'll travel, of course. It literally says in the problem, 1,200 miles away. So 1,200 miles, that's the total distance, right? 600 plus 600. Now, what is the total time? Again, we know that 8 hours for the first part, and then we have 12 hours for the second part. And since we have 8 hours for the first part and 12 hours for the second part, all we really have to do is we can just divide it by that amount. So now it's just going to be 12 plus 8. So it's just going to be equal to 60. So the average speed is 60. Any questions? So this 1,200 is the total number of miles. There's going to be 12 hours for the first trip, right? 8 for the second trip as we calculated. And then it's just going to be 60. And again, the first part was not that hard. We just do the second half distance divided by the time by calculating here. This is not the answer, yeah. So are there any questions? Okay, let's move on to number 2. David went to Reno on a train traveling at 60 miles per hour and came back at 50 miles per hour. It took him 1 more hour to travel back and getting there. And we're asked to find how long the whole trip took. Okay, so here's how you can do this problem. Let's say the total distance, or the distance between Reno, let's call distance, so the distance to Reno, let's say it's D. So then we don't have to write this phrase every time. So D is distance to Reno. So now we have that the distance to Reno divided by 60 is how long, right? This is the time is going to be the distance divided by the rate or the speed. So this is the time for the first part of the trip when you go there. And when you come back, the time is just going to be, you don't actually want this for now. The time is just D over 50 for the second part of the trip. Right? Is everybody clear on that? Okay, good. And now we know that it took him 1 more hour to travel back than getting there. And that means that this quantity, the time for the second half, is going to be 1 more than this quantity. So that means that D over 50 is equal to 1 plus D over 60. This means that, well, 60 over 300 equal to 1 plus 5D over 300. Which means that 60 minus 5D over 300 is equal to 1, or D over 300 is 1. This in turn means that D is equal to 300 times 1, or just 300. And we're not done yet. Now we just have to find the total time. That shouldn't be that hard, because we know the total distance is 300. The time for the first part is 300 divided by 60. And the time for the second part is 300 divided by 50, which gives us an answer of 5 plus 6, which is 11. Any questions? 11 hours. And again, just to be clear, hours for first part, and this is for second part, the number of hours. Because again, we just found here that D is 300, so this is the 300 is the distance, and 60 is the speed, and 50 is the speed for the second half. Yeah. Any questions? Zoe left San Jose at 30 miles per hour. Let's just say that Zoe left, or let's just say that San Jose, so I'll just write it here. And then Zoe left it, so Zoe at 30 miles per hour. So 30, let's write it 30, mph. And after half an hour, Sue left from San Jose, traveling in the opposite direction. So I should probably move this. So Sue is going to go from here, going to go in the opposite direction, at 40 miles per hour. So 40 miles per hour. It's going to be, Sue is going to leave that. So Sue's the blue one. This is Sue. This is Zoe. But then you see that Zoe travels for half an hour more. So basically we say that after half an hour, Sue left San Jose at 40 hours, and then after half an hour, Sue left San Jose. And that means that, so first that Zoe gets a head start of 30 minutes. First Zoe gets 30 minutes, and Sue doesn't get any. But then after 30 more minutes, Zoe gets an additional 30 minutes. And then after that, Sue leaves after 30 minutes, right? And then Zoe still gets another 30 minutes because half an hour after Sue left San Jose. And Sue gets 30 minutes. Sue also will get 30 minutes, half an hour. Or now we can see that Zoe will run a total of 60 minutes or an hour, or 1 hour. And maybe I should have just left it in terms of half an hour, but Sue will just have one half hour. Because again, remember, units, let's deal with only hours. So I should probably written these as hours, but it's okay for now. So half an hour, 1 hour for Zoe, half an hour for Sue. But then we see that Zoe can travel 30 miles in 1 hour. So then we just do 30 miles per hour times 1 hour, which is 30 miles. But then for Sue goes for 40 miles per hour, but for only half an hour. This is just going to be 20 miles. And then after half an hour, so then it's going to be something like this. Zoe will be 30 miles here. And then Sue will be here, 20 miles. After half an hour. This is the final position I just drew. So then there's going to be 50 miles apart, right? 20 plus 30, 50 miles. Any questions? Okay, let's try number 4 now. Bryce left in a car, headed for Grand Canyon National Park 3 hours before Candy, traveling at 80 miles per hour. It took Candy 5 hours to catch Bryce. How fast was Bryce traveling? Okay, so let's try to see what's going on here. Bryce left in a car before Candy, and then so Bryce left in a car for let's just say that this is Grand Canyon. So I'll try to C for Canyon. So Bryce is here and left in a car for Grand Canyon. So something like this maybe. 3 hours before Candy. And then it took Candy 5 hours to catch B. And then Candy also leaves Candy will leave after 3 hours later. And then it's going to also reach Grand Canyon. We're not going to reach Grand Canyon, but they're going to meet up at some point. So let's just say that Grand Canyon is somewhere here, actually. So they're going to meet up at some point. We don't know where. So let's just say they meet up at some other point. Maybe here. They meet up here. Because we have that Bryce is traveling faster, except that Cindy gets the head start. So eventually they're going to catch up, if that hopefully makes sense. Okay, so how long? It took Candy 5 hours to catch Bryce. So overall, Candy can ride for 5 hours. And then Bryce, well, she got a 3 hour head start, but then there's an additional 5 hours when it's the hours that took Candy to catch Bryce. So it's going to be 5 plus 3 or 8 hours. So 8 hours for Bryce, 5 for Candy. Now we see that, okay, 8 times whatever speed that Bryce was going at. So 8 times whatever Bryce's speed. So Bryce speed. The BS just means, or else write it as, we write on the side actually. B is Bryce's speed. We don't know what it is. We know Candy's speed, right? 80. So the distance that Candy will travel, which is going to be, the distance Bryce will travel is going to be 8 hours times the 50 miles, or not 50, the B miles per hour that Bryce will go at is equal to, this is just going to be equal to 80 times, well, the amount of hours that Candy's going at. So you know that goes to 80 for 5 hours. So it's just going to be 80 times 5 hours. So 80 miles per hour B miles per hour, and H 8 hours. So I should write that. So hopefully that's clear. So now we just do 8B is 80 times 5 or 400. That means B is 400 divided by 8 or 50. Average travels in a car to Crater Lake National Park at 40 miles per hour and returns to the national park at 60 miles per hour. It took him 15 hours to get there. What was his average speed for the whole trip? Okay. So this problem, basically we have that Avery is going at 40 miles per hour. So 40 miles per hour for 15 hours. But then he comes back at 60 miles per hour. So he goes back in this path, 60 miles per hour and some hours. So we have the total distance, which is going to be the speed, 40 times the time, to 600. But then we also know that it's going to be 600 divided by 60, which is 10 hours. And we're given that, well, it takes 15 hours to get there and 10 hours to come back. And it's going to be 600 on each path. We've just found that out, right? Distance is 600. So 600 on the way there, 600 on the way back. 1,200 total miles, right? 600 on the way there, 600 on the way back. So 1,200 total miles divided by 10 plus 15 hours, which is just going to be 1,200 divided by 25, which is 48. Any questions on this problem? Okay, let's move on to the next problem. Flying through to Hawaii, it took 5 hours to get there and 6 hours to get back. The average speed on the return trip is 500 miles per hour. What is the average speed on the way there? And what is the total distance traveled? Okay, so the average speed on the return trip is 500, and it takes 6 hours to do that. So what is the distance? What is the distance between himself and Hawaii? Distance is speed times time, and the speed is 500 miles per hour, and it takes 6 hours. And that will just be 3,000 miles. So 3,000 miles, and now what that means, we have to find the average speed on the way there. Well, of course we know it's going to take 5 hours to get there. And that means that we have time is distance divided by the speed on the way there. And we don't know what that is yet. So we have the 3,000 miles that it takes to go there. It takes 5 hours to get there. So this should be 5. T is 5. So the time is going to be equal to the distance divided by the speed, whatever the speed is. Or another way of writing this is, a shorter way probably would be that the speed is just 3,000 miles divided by 5 or 600. So the average speed on the return way is just going to be 600 miles per hour. So any questions on this part? Okay, now let's try the second part. What is the total distance traveled? Okay, so the total distance traveled, well, 600 for the speed is going to be on the second part. So total distance traveled is just going to be 3,000 on the way there, 3,000 on the way back, so 6,000. These are our answers, 600, 6,000. Any questions? Okay, let's try number 7 now. Elaine has 3 hours to get home, which is 120 miles away. Except she's stuck in traffic for the first 30 miles, only going at 20 miles per hour. So what is the average speed she has to go for the rest of the way to get home on time? So 3 hours to get home, 120 miles. So for the first 30 miles, let's divide into chunks. 30 miles, 90 miles. Okay, so for the first 30 miles, they go at 20 miles per hour. And we have to find what's the average speed to get home on time, which is in 3 hours. So does anyone know where to start? And yes, exactly, we can start to find the time it takes to travel this first portion. So how much time will this take? Well, the time is just going to be the distance, 30 miles, by the speed, 20 miles per hour, which is 3/2 hours, right? And then, well, then we know that 3/2 hours for this part. This part must also take 3/2 hours, right? Because we have to finish in 3 hours. So the total has to be 3. And 3/2 plus 3/2 is indeed 3. And therefore, we have that the time for the second part. Well, sorry, T2, because it's the second time. Sorry, not the time, but the second part. The average speed she has to go for the second part, so the speed is going to be the distance by the time. The distance is 90, the speed is 3/2, which is 60. So the answer in this case is 60. Any questions? And whenever you're getting confused on these speed problems, just visualize it. It's much easier to visualize it. So you can draw, okay, Elaine is here. She's stuck in traffic for this 30 miles. And then how long does it take? And then maybe you can see, oh, maybe we can just use the distance formula. Or maybe we can just use these formulas, average speed formula, or something like that. So you can always do that. Okay, let's try number 8 now. Jessica hiked from point A to point B at 4 miles per hour, B to C at 3 miles per hour, and C to A at 2. The distance between every 2 points is the same, both. We have to find the average speed. So what we do is it can be, okay, let's just say that we have A here, maybe B is here. There has to be an equilateral. Let's just draw a triangle. So A is here, B is here, C is here. And again, drawing the diagram can help you visualize it. So that's why I'm drawing a diagram. 12 miles. It's not a very good equilateral triangle. It's okay as long as you can see what's actually going on. So this is B. Again, 12 miles. And 12 miles. So then we know that Jessica goes from A to B at 4 miles per hour. B to C at 3 miles per hour. And C to A at 2.4 miles per hour. And let's find the average speed. So what is the formula for average speed? Total distance. So total distance, what is the total distance? Does anyone know what the total distance is in this problem? So what is the total distance that Jessica will travel when she's hiking around the diagram? She goes from, I think I should have written 2.4 miles per hour. So does anyone know what the total distance that Jessica travels from A to B, B to C, and C to A? Yeah. So some of you said that's going to be 36. So 12 miles times 3, because it goes from A to B, B to C, and C to A. So 3 of these paths, so because it's a triangle, so 36 miles. So 36 miles. And now we have to find the total time. So we can just find the time for each of the line segments from A to B, B to C, and so A to B, A to B, B to C, and C to A. So what's the time that takes from A to B? It's just going to be 12 miles divided by, so time is 12 miles divided by 4 miles per hour, or 3 hours. The second part is T1. T2, for the second side length, is going to be 12 miles by 3 miles per hour, just 4 hours. And T3 is just going to be 12 over 2.4, right? For 5 hours. Which is 3 plus 4 plus 5, which is 36 by 12 and 3. So 3 hours, 4 hours, and 5 hours. And then again, we just sum up 3, 4, and 5. 3, 4, and 5 hours. And the 36 miles, right? Total 12 times 3. And just going to be equal to 3 miles per hour. So any questions on this problem? Let's do number 9 now. George drove to Acadia National Park at 60 miles per hour. And after 3 hours, Hillary drove at 75 miles per hour trying to catch George. At what distance would they catch up? So how can we do this? Well, we know that George is just going to drive at 60 miles per hour. And after 3 hours, Hillary will drive at 75 miles per hour. So George is going to get an additional 3 hours to go. Okay, so George is going to go there. Hillary is going to go from here. Okay, how long will Hillary take to catch it? We don't know. We just know it's going to be some speed s. Let's just call it, right? And George, how long will? Sorry, this is some time t. That's how long. That's how long Hillary will take to catch George. And how long will George have then? George is going to have an additional 3 hours, so t plus 3. And now we know that after some time, maybe they're going to catch up. They're going to catch up at some point. And we know that the distance that George travels is equal to the distance that Hillary will travel. So what is the distance that George will travel? 60 times t plus 3. This is going to be equal to 75 times t, right? So t is the time, and 60 is going to be the miles per hour for George, and 75 is the miles per hour for Hillary. And now we can just solve this equation. We get 60t plus 60 times 3 or 180, 75t, which means that 15t is 180, or t is 180 divided by 15, or 12. So now we know this t is going to be 12. Hillary is going to drive for 12 hours, and George will for 15. Okay, so then how far will Hillary travel? Hillary will just travel 12 times 75, which is indeed going to be our answer, or 900. This is the speed. This is the time. But there's actually a way we can check our work. And we can just say, okay, will George also travel the same distance? You can see that, okay, 15 hours for George times however he's going at 60 miles per hour is 900 miles. We see that these are equal, the same number of miles. And that means our answer is correct. 900 is indeed correct. 900 is the answer. Any questions? So let's do number 10 now. Kaylee drove from San Jose to San Diego, distance of 40 miles. After 3 hours, Larry started to drive from San Diego to San Jose. And they met another 3 hours of driving. And Kaylee drove 20 miles per hour faster than Larry. We have to find how far away they meet. So let's draw a diagram. So San Jose and San Diego. San Jose, San Diego, 40 miles. Okay, so after 3 hours, Larry started to drive from San Diego to San Jose, and then they met after 3 hours of driving. Kaylee drove 20 miles per hour faster than Larry. And how far away did they meet? So what we can do in this problem is we can notice that, so it's distance of 40 miles, after 3 hours, Larry started to drive, and they met after another 3 hours. So Larry only drove, so Kaylee drives from here, so Kaylee was going to drive, this is going to be Kaylee, and then you have that, now we have the Larry is going to drive also. And we know that after 3 hours, Larry started to drive from San Diego to San Jose. They met after another 3 hours of driving. Okay, so Larry only drives for 3 hours. However, Kaylee drives for 6 hours. 3 plus 3. 3 hours and plus another 3 hours, right? Because she's driving the whole time. And how fast are they going? Well, we don't actually know how fast they're going. Well, we can say some variables for how fast they're going. So we know that Kaylee is going at some speed S miles per hour. And that means Larry, since he drives 20 faster, is going to go to some speed S plus 20. And what does this mean? Well, the total distance is just going to be. So now we can find the total distance in terms of that. Sorry, that should be S minus 20. The total distance is 6S, 6 hours, S miles per hour, plus 3, S minus 20, is 40. Yeah, so because Kaylee drives 20 miles per hour faster than Larry, so Kaylee, this S is going to be 20 more than this S minus 20, which is at 6S, is 3S, minus 60, is 480. That means 9S is 540, or S is 60. Okay, so now we know that Kaylee's driving at 60, and Larry's driving at 40. Right, since Larry is 20 slower. So how far from San Diego did they meet? Well, we know Larry is going to drive for 40 miles per hour for 3 hours, which is going to be 120 miles. Any questions on this problem?